All right, let's talk about engineering project management. Here's what we're going to cover. First of all, what is project management and why do we need project management? Why do we care about that? We'll talk about what a project lifecycle is, the roles of a project manager, and we'll spend some time on tools for project management because that's part of your assignment. So let's get started. First of all, project management is exactly what it sounds like. It's either a person or a team of people who manage the entire project. Project managers plan, organize, and oversee the entire project from start to finish. They manage tasks, resources, timelines, and budgets to achieve the project goals. They prioritize these tasks. They try to reduce risk. They track progress, and they need to solve problems. They also have to bridge technical work with real-life constraints like cost and time and scope. So they need to keep an overview of everything. They keep what I call the 30,000-foot view, overseeing everything, the big picture of the project. A project manager can be either a technical or a non-technical role. It could be that a senior engineer is filling the role, or it could be somebody with a business background. The project manager is the party planner. Now, seriously, project management is like being in charge of throwing a gigantic birthday party. The project manager is the one who makes sure everything gets done on time, like reserving the venue, ordering the cake, booking the entertainment, inviting the guests, even decorating. Now, they don't have to bake the cake or blow up the balloons themselves, but they do need to make sure that those people who do know how do it, and do it on time. The goal is to make sure the party goes smoothly, that everyone has fun, and importantly, it doesn't go over budget. All right, so that's what a project manager is. Well, every project, whether it's a big project or a small project, follows a similar path. It's called the project life cycle. So whether you're designing a new bridge or creating software or throwing a massive birthday party, these 5 stages help ensure the project is completed successfully. Number 1, there's the pre-project part. The budget and contracts are negotiated and signed before the formal project management phase even begins. This includes some preliminary project management because when negotiating the costs, you need to include estimates for materials, labor, resources, and contingencies. But once the contract is signed and the budget is set, this constraint then limits everything else that comes after in the project. Everything needs to come in under budget and on time, or the contract needs to be supplemented or renegotiated, or else the company takes a loss on the contract. Initiating is where everything actually starts. We define the purpose of the project and set clear objectives for the project. We ask ourselves questions like, what problem are we trying to solve? And what does success look like when we do solve this problem? Next comes planning. This is where we get detailed and we drill down. We outline what needs to be done. You figure out the timeline. You decide who will do what work. You think of it as creating the roadmap for the entire project, and without this, you're driving blind. Executing is the action phase. Here we actually carry out the task and start building or developing. The project manager will coordinate the teams, ensure that the resources are available when they're needed, and make sure that everyone's doing their part because they have to track things along the way. And this is the next part, because while the work is actually happening on the project, there has to also be a monitoring and controlling phase of the project. This means tracking the progress of the project, making sure everything stays on schedule and within budget. If something goes off track, like a delay or an unexpected problem, the project manager steps in to adjust the plan and to solve the problems. And then finally, we reach the closing phase. This is where we wrap up the project, we deliver the finished product, and then you review how everything went. Did we meet the objectives? Did we learn anything along the way? It's like putting the cherry on top of a well-executed plan. Some people call this the post-mortem. So you review what you did in the end. All right, so let's talk about the roles of the project manager versus the project engineer. Those two roles are not the same, but they're supposed to complement each other on any project. First, the project manager is responsible for the entire project, overseeing timelines and budgets and resources, absolutely everything regarding the project. That's their job. They're also the main point of contact for customers or stakeholders or clients and the project teams. So if the teams need to know something, they'll go to the project manager. The project manager then is kind of the communications center. They're going to ensure that communication flows smoothly and any issues that arise are quickly taken care of. Now, I mentioned this before, but this is an interesting point. The project manager may or may not be an engineer or even have a technical background. Some project managers come from business or management and they have like a business background, while others are former engineers who transitioned into that management role. By the way, that is something that happens a lot. It's common for engineers to transition from engineering into management. Now you might say, well, why is that? Well, that's because for many engineers, management is where the money is. As engineering firms grow, often their projects grow also in size and complexity, and companies then value the leaders who are within the company who understand both the technical side and the business side of project delivery. So, does it help if the project manager has a technical background? Well, it can, especially when dealing with complex engineering problems. A technical background then allows them to understand the challenges that these teams are going to face and make more informed decisions. However, a strong project manager doesn't have to be an expert in the technical areas. They just need to understand that the team has the right experts on their teams and that those experts are working efficiently. Sometimes not being technical can actually help the project manager stay focused on the overall project without getting trapped in the details and bogging down along the way. Now, on the other hand, the project engineer is responsible for the technical execution. They're the ones that are designing, developing, and implementing solutions that meet the project requirements. They may be in charge of teams as well, but they are in charge of assigning the tasks to the team and making sure that the teams get it done. So the project engineer handles the details, whether it's creating like a design or solving engineering challenges or making sure that everything functions correctly. The project engineer is almost always going to be some sort of senior engineer. And they work closely with the project manager to make sure that the technical work aligns with the overall project goals. Now, it's debatable whether the project engineer should be considered part of management or not. The project engineer can have some management-like responsibilities. They might manage the day-to-day tasks of junior engineers, say, or coordinate design teams or something like that. But they manage technical work. That's their job. They do not manage the entire project from a high-level perspective like the project manager is going to do. Ultimately, though, both of these roles need to collaborate closely. The project manager keeps the 30,000-foot view, ensuring the project's on track, while the project engineer focuses on the technical execution and the problem solving. And together, they make sure the project is delivered successfully, whatever that project is. All right, a project manager has certain processes and techniques and frameworks that they use to do their job. These things are collectively part of the Project Management Body of Knowledge. That's the PMBOK. You can think of the PMBOK as tools in the toolbox of a project manager. Now, a lot of these tools that the project manager learns and uses are the types of things that are actually taught in graduate school to somebody who's going to be pursuing an MBA, a Master's of Business Administration. In fact, it isn't uncommon for engineers to do something like this, to get an undergraduate degree in engineering and then a master's degree that is an MBA. So some of the tools of project management are well beyond the scope of this class. However, here are a few of the most prominent processes, techniques, and frameworks used by project management. First of all, the project charter. That's a document that the project manager creates. He creates it early in the life cycle, and that's the document that formally authorizes the project to begin. The work breakdown structure, that's the WBS. You're going to create one of these as part of your assignment this week. The WBS is a way to break down a project into smaller, manageable tasks and deliverables. You will use WBS in the assignment this week, like I said. Then we have Gantt charts. A Gantt chart is a visual tool that schedules tasks over a lifetime. It shows starting and ending dates. You've got, if there's task dependencies, then it shows that. It shows the duration of the task. What I mean by task dependencies is that task A has to be finished before task B can begin. Sometimes A and B could be started at the same time, but other times one has to finish before the other can start. That's called task dependencies. And Gantt charts, this is also something we will use in this week's assignment, which I'll tell you more about here in a little bit. And then you have other things like Array C matrix. This is a methodology where a project manager assigns roles and responsibilities, and it clarifies who is responsible, who is accountable, who's been consulted, and who's been informed. That's what the RACI stands for: responsible, accountable, consulted, and informed. And then they have other things like a risk management plan. It identifies the risks, it analyzes the risks, and it tries to come up with mitigations for the risks. Then you have a communications plan. Now, this is actually a formal document that outlines how and with whom information will be shared throughout the project. Like, are we going to have daily status reports? Are we going to have weekly meetings? Who does those meetings and who gets to attend the meetings? Things like that. That is the part of the communication plan. And these are just a few of the tools that a project manager would use. There are many, many more. And these have names like what you can see there. I'll leave it up to you to read those. All right, so since we're going to do a WBS, it's important that we talk about it. So what is a WBS? You can think of a WBS as sort of an outline for the entire project, where you break the project down by levels. Let's read through this. Level number 1, that's the overall project. An example of that would be like, okay, if the overall project is to build a house, level 1 of the WBS is build a house. And then level 2 is where you take that major tasks of level 1 and you break it down into smaller tasks. For example, you have to prepare the site that the house is going to be built on. You have to make sure that you do a foundation. Then you have to do framing, and then you have to do finishing. So that one major task of building a house is now divided up into 4 or more, ever how many tasks you need to make sure the project is completed. And then you break each one of those tasks down. For example, let's say you look under foundation. All right, well, foundation includes things like excavation, pouring footings, making sure the concrete meets all of the requirements. All of those things are necessary under foundation. But then you can take each one of those and break it down farther into more detailed tasks. For example, under pour footings, well, you could say, okay, we need to prepare the formwork. We need to order the concrete. We need to inspect the footings pre-pour. In fact, that may be a requirement of city or county codes wherever you're building, that an inspector comes out from the local authorities and inspects things before you pour your concrete. You need to make sure that all of those things happen. And you could even go further down. You could have level 5, level 6. But if the project is, say, a simple project, You may only have a couple of levels, and a more complex project could have even more levels than what we show here. Like I said, it's similar to an outline, like something you did in your 8th grade, where you outline, say, a paragraph or a book. You have an outline title, that's like level 1, and then underneath that, Roman numeral 1 could be the major phases, and then under that you have like capital letter A, and then under those you have numbers like 1 and 2 and so forth, and then under that you have like small letter A, B, C, and so forth. You keep breaking it down into smaller and smaller pieces. So the WBS then is you take your project and you break it down into smaller and more manageable tasks. All right, then we get to a Gantt chart. This is a Gantt chart, and a Gantt chart is a way to display the tasks from the WBS. And it can show that in a timeline and the task dependencies. This Gantt chart here shows the tasks over here on the left-hand side. You can see it's broken down into 1, 2, 3, 4, 5, 6, 7, 8, 9 different tasks. Across the top we have dates, and you'll notice they probably are weeks, like February 1 represents the beginning of that week, February 8th the next week, 15th, 22, like that. So each one of these squares here represents a week of work. Well, you'll have a week of brainstorming, and then say starting in the middle of the next week you'll do a web-based and literature research. That could be something like looking up the codes and things like that. And then you have your first prototype, and you'll notice the first prototype starts before the lit review or the lit search is finished. And then you can construct the track. You know, I don't know exactly what this was for. I got it from another source, but it kind of looks like maybe it was for building some sort of go-kart or a racing vehicle, something like that. So you build the prototype, but you have to construct the track, and you can do those two things at the same time. It looks like building the prototype will be finished first before the track is fully constructed. And then after the track is fully constructed, then you can go test your prototype. Somebody's going to have to do progress reports, which will take place sometime in this region. And then after you've tested things and you get back your results, you analyze them, you redesign, and then you retest. Somebody's going to have to write an instruction manual, and then at the very end of the project you have the final demonstration. That is for the customer to review. You'll have the customer present at the final demonstration. All right, so that's a Gantt chart, and yes, you will create a Gantt chart this week. And I have a video I want you to watch that will show you that. But there are other things. For example, here is another Gantt chart that has more details on it. You won't create this kind, you will create the kind that was on the previous page. But look here, you can see that certain things have been assigned. So we have names like Mike Smith, he's 100% through with that. Like the percentage that's at the end after Mike Smith's name says that he is 100% completed with that task. And then he's 59% completed with this task, and then 100% completed with this task. And whatever this, you see this gray bar up, we're not seeing the whole Gantt chart here, so that represents the end of Mike Smith's task here, whatever that task was, and we can see it over here on the left-hand side. So 11/1/2017, that represents that date right there. And then we have the design phase, and the design phase is going to run from this date to that date. Looks like Jennifer Jones is 100% completed with database design, and it looks like she's 56% complete with software design. She's 100% complete with interface design, 37% complete with create design specification. But the whole project, this design portion ends on February the 2nd, so she needs to be complete by then. This dash line right here may represent, say, the current date when this was printed out. So if that's the current date, at least it's behind this right here. It looks like Mike Smith is behind when it comes with discussions with stakeholders. He should have already finished that. Okay, and then we have the development phase that runs from this date to that date. and who has been assigned tasks there. And then we have the testing phase, and it looks like Mike Smith's back for that. All right, but that's a snapshot of something that I saw online that is a Gantt chart. And it's a Gantt chart that includes task dependencies, and it also includes who has been assigned to certain tasks. All right, now this is a different kind of chart. This is what's called a PERT chart. PERT. PERT stands for Program Evaluation and Review Technique. This is another one of the tools that a project manager would have. This A, B, C, D, E, F, and so forth, those represent milestones of the project. And if you look here, here's milestone A, and then milestone B, and then milestone C, but D is down here coming off of A as well. What that means is that at project initiation, you can start working towards milestone B, whatever that happens to be, and milestone D at the same time. So you could have people assigned to B and different people assigned to D. And this arrow right here represents the number of days. So that should take about 3 days in order to, after initiation begins, for milestone B to be completed. But milestone D requires 4 days. But after B up here, you can go on to milestone C, and that takes 5 days. And then from C to E, that takes 2 days. If you add these up, that's 5, 6, 7, 8, 9, 10. That's 10 days to go from A to E. But look down here, for go from A to D, that's 4 days, and then from D to E, that's 8 days. So that's 8, 9, 10, 11, 12, that's 12 days here. So this bottom path to E is a couple of days longer than this top path to E. So we would say there are 2 days of slack time on this top path here. But you'll notice both of these tasks, whatever they are, like maybe this is hardware development across the top, and this is software development across the bottom. All of those tasks have to be done, both hardware and software, so that you can get over here to task E. And maybe task E is integration, where you start putting the hardware and the software together. So both of those hardware and software components need to be completed before you can start E. Well, this bottom path down here represents what's called the critical path. There's 12 days in it, and you've got 2 days of slack time up here. So that means these folks here can mess around for 2 days that are working on this upper branch. But these folks down here at the bottom, their task is one that's going to take 12 days, and all of this needs to come together 12 days after initiation over here at A. So these arrows here, you see how there's a difference in the look of these arrows. The arrows that are double lined like that, that represents the critical path. This is the one that everybody needs to stick to. And over here, there's another critical path that goes across the top. And if you add up these days, looks like there's 9 across the top there. And there's 4, 5, 6, 7, 8. So we've got how many slack days do we have here? We've got 1 day of slack time across this bottom path. Whereas this top path of 9 days, that's the critical path. So a PERT chart like this shows tasks dependency, because B has to be done before C, and it also shows slack time, and it shows critical paths. All right, that's what a PERT chart does. Here's another PERT chart, and this one is for building a house. 0 up here, that represents the beginning of the project. That's initiation. And then it takes 4 days to excavate. So 1 represents excavation. And then after that, it takes 2 days to pour the concrete. So pour the concrete is task number 2. And after that, we can start erecting the frame. And that takes 5 days. But then after the house frame is erected, then we can break it up into some parallel tasks that can be done at the same time. For example, across this top, we can frame the roof and install the shingles. And then down here, the outside walls can be done, and then you can paint the exterior. And then this inner portion here, well, you can break it up into rough plumbing and rough wiring, but those two things have to come together at this milestone here so that you can begin installing the interior wall boards. That could be drywall, or it could be brick walls, or it could be wooden walls, whatever the interior walls may be. All of the rough plumbing and the rough wiring needs to be done before you cover that stuff up. Okay, and then after that, after the wall boards are installed, then you can do the plumbing fixtures and the electrical fixtures and the interior paint. And then you're finished. So 12 probably represents closure here of the project. All right, so that's a PERT chart for building a house. Here's another PERT chart. I won't go over this one, but you can look at it. You can pause the video, take a screenshot, whatever, so that you can study it in a little more detail. And you can see the tasks have been named down here at the bottom. And we're talking here, it looks like the tasks take weeks. So you got 2 weeks there, 4 weeks there, 3 weeks there, and so forth. I'll leave it up to you to look at that on your own. All right, so now we get to the assignment. So you have seen examples of WBS and Gantt charts. I want you to build these things. So here's your assignment. You will create a work breakdown structure, that's the WBS, to identify tasks. And you'll create a Gantt chart to schedule those tasks and assign the responsibilities and add task dependencies and so forth. So let's read this assignment. You are tasked with managing a small project to build a popsicle bridge. Okay, so you are the project manager. Your goal then for this assignment is to break down the project into tasks. Then schedule them using a timeline, assign the responsibilities, and like I said, show the task dependencies to reflect how one task must be completed before another can start. So these are two different things that you need to do. You need to do the WBS and you need to do the Gantt chart. But I want you to do them in a single Excel file. So you can put the WBS on, say, sheet 1. And then you can put the Gantt chart on, say, sheet 2. You can name those sheets however you want. If you've forgotten how to create new sheets, you can go back and review the videos at the beginning of the semester, or just look down at the bottom of your Excel page and you'll see there's a plus sign there. That's how you can add additional sheets then. All right, so that's the assignment. Here is an example of a WBS. For example, here we've got the levels over here on the left-hand side, and then here are the tasks. Now, the things across the top here, those are just headings for these columns. So top level, level 1, Popsicle Bridge Project, and you're assigning this is assigned to the project manager. And then you'll have a design phase, and that's the design team. And then you'll research bridge designs. Well, designer A is going to do that, and designer B then is going to create the design sketches. Then you'll have a construction phase, and the construction team is going to do that. Now, your WBS should not necessarily look exactly like this. You may want to add even more details in, add even more levels, but this is kind of what I want you to do. So this is what should appear on the first sheet of your Excel program. This is the WBS. So this is the general structure, the general outline of what I want you to do. And you can put names of your team members over here. Since you've already built a popsicle bridge, you could use that as your example. Or you can just, give them generic names like the construction team or procurement or the construction lead, something like that. But this is the general look of what I want your Excel spreadsheet to look like for the WBS. Then let's go to the Gantt chart. I have included a link to a video of how to make a Gantt chart in the assignment message. Now, it's a short video. It goes really fast. I had to watch it 3 or 4 times before I could duplicate whatever they were doing in that video. But keep in mind, you can always pause and rewind and watch that video multiple times. It's only like 2 or 3 minute video. All right, but now I want to give you a few pointers here. So what you see on this Excel spreadsheet here, the tasks that are over here on the left-hand side, those should match what is in your WBS. So each one of these should show up here, but they should also be in that first sheet. And then we have the start date and the end date. All right, now I want to give you a pointer here because this shows time. You see it shows time, it shows date and time on each one of these. You don't have to display the time. Just display the date. Because I've discovered that Excel doesn't really work well if you include times. So just include the date. And the minimum amount of time that I want you to do for any one of these tasks is 1 day. So just do 1 day as the minimum amount of time. Even if it takes you half a day, just give yourself a full day to do whatever this task happens to be. So that one takes 1 day there, that one takes 1 day there, 1 day there, 2 days for that one right there. So be sure that they're integer number of days in the duration column, and then who that's been assigned to, and that also should match the WBS from the previous sheet. But you add this column right here, this is task dependencies. You'll notice that this task, the create design sketches, has to be done after you research the bridge designs, which was this task up here. And then this one, it depends upon create design sketches. So you create design sketches in this task, but that create design sketches has to be done before you can begin procuring your material. And then this one follows that. Okay. Now some of these could start at the same time if you wanted them to. It's just up to you how to do that. What you will see here on this one is the start date is here and the end date is there. And for this example that we see right here, everything takes a day and the next one starts the day after. Yours doesn't have to be like that. For example, you may want to start the procurement of the material on the 5th, but you also could start build the bridge structure on the 5th. So you could start both of those on the same date. Build the bridge structure could go for 9 or 10 days, whereas your procurement of material maybe only takes 1 day like this. So you could have parallel tasks going on. But those are a few pointers. The biggest one that I found that messes you up is don't use the time and be sure everything is in units of days. So when you make your Gantt chart, this right here that you see here is actually the data that is used for the creation of your Gantt chart. You'll enter the start and end dates of each task. Don't include the time, only the date. The Gantt chart is made with Excel, and be sure and watch that video. Again, what you see here on the screen is only an example of the data that you will use to build your Gantt chart. Yours should not look anything like mine. But the data that is here corresponds to the tasks that were created in the WBS. All right, so go watch that video, learn how to make a Gantt chart from your data. It's a good video, but like I said, it's fast. I expect you will start and stop it often to see what is being done. But if you pay attention to what's happening on the screen, yeah, you can do it easily. Anyway, that's the assignment. Let me know if you have any questions, and I hope you have a great week. Hang in there.